All right, so today, final exam review of key concepts from Unit 3 on circular motion and gravitation. Do you remember this one? I'm feeling like this is the one most people's final exam is going to replace. I don't know why I feel that way. Maybe it's because you guys crapped the bed on this test. I don't know.
Oh, look at me.
Okay. So, key concepts from this unit. There's going to be a bit of multiple choice about the principles of circular motion in general. All right. So, circular motion occurs if there is a centripetal force . Okay, a centripetal force obviously causes a centripetal acceleration. Okay, so that's mv squared over r. Okay, this is v squared over r. Okay, what's different is essentially this is mass times acceleration. Something will only move in a circle if there's a force pulling it towards the center, causing it to accelerate towards the middle. Okay, so that means that in uniform circular motion, an object is traveling at a constant speed, but not a constant velocity. Okay? The velocity is not constant because its direction is always changing, always being pulled towards the center. Okay? So there's probably going to be a multiple choice question or two about that idea. Now, centripetal forces can be provided by lots of other forces that we're familiar with. Gravity, friction, normal force, all of that kind of stuff. What you have to be able to do is identify what is acting as the centripetal and thus net force for uniform circular motion, or for vertical circular motion, use all the forces to calculate the net force. Fc is our net force after all, right? That's why we go forces in minus forces out. That's the vector sum of all forces for something moving in a circle. Okay, so the examples we went over in class of uniform circular motion were artificial gravity, banked curves, and unbanked curves. Expect that you're going to see one of those three as your uniform circular motion problem on the final exam. Okay. What provides the centripetal force on an unbanked corner? Friction. Okay? Friction is what keeps you from sliding. If you're on a banked curve, what provides most of the centripetal force? Normal force, right? As I'm going around that bank, okay, remember that bank is really an inclined plane, right? The normal force acts straight out from the surface, okay? Because normal force can only ever be perpendicular to the surface that is providing it. But two things are going to contribute to that normal force. It's a little bit different than what we learned in Unit 2, where in Unit 2, it was just gravity that pulled the object into the plane and then normal force pushed back. That's fine if it's just sitting on the plane. But this is an object that's going around a circle that is inclined. That means its inertia wants it to go in a straight line. So it pushes even harder. Gravity pulls it down into the surface, and its own inertia pushes on the surface as well, which actually makes normal force the bigger part of that corner. So we've got gravity, and we've got centripetal force, okay, as that horizontal part. Okay, that's where that comes from. I'm not going to ask you to derive this. I'm not going to ask you to draw this. I'm just explaining it again so you understand where it comes from. Okay? And that's where the whole formula of this angle here, which is the same as this angle, is related to, okay, the force of gravity and the centripetal force. And then obviously for artificial gravity, we're just using a spinning drum. Okay, your inertia wants you to go out at a tangent, but the drum, the inside of the drum pushes on your feet and makes you feel like you have weight. Okay, so Fc just equals Fg for those. Okay, for vertical circular motion, okay, that's this. Fc equals forces in minus forces out. How many positions on a vertical circle did we talk about in class? 3. All right, those 3 were bottom of the circle on the inside, top of the circle on the inside, top of the circle on the outside. Okay, which one of those 3 has a minimum speed? One in the middle. Okay, you can't fall off of or out of the circle in the other 2. Okay, because you're sitting on the circle in the other 2, so there's no danger of falling. There's no minimum speed you have to achieve to stay there, right? But when you're going under the top of the vertical circle, you could fall out if you don't go fast enough. Okay, if you don't go fast enough, you could fall out of there, all right? Now, actually, I don't think I showed you the guy running through the circle, did I? Okay. Not the running one. All right, so there is a minimum speed at the top of the vertical circle. Okay, if I don't go fast enough, just like him, I fall out. Okay, or the roller coaster, but roller coasters don't because they're built to not do that. Okay, but yeah, you have to have a minimum speed here. Now, what forces are acting on you in each one of these situations? Okay, what's this force? Okay, what's this force? Normal force. Okay. What's that force? Gravity. Force of gravity. Now, if I'm traveling at the minimum speed, that's it. I'm not pushing on the track. And you can actually see that when they slow-mode him going over the, or going around the top there, he was barely touching the circle. Okay? If you looked at what his legs looked like as he was running through the circle, his knees were really bent as he was going around, like up the circle. But as he got near the top, you could already see he was falling. And so when he put his feet on the top on the inside, he barely touched that circle. Okay? He was going just fast enough to stay inside, so there was no normal force pushing on him. If he were to run faster, or if this was a roller coaster or something that did go faster than the minimum speed, then there would be an additional force, a normal force. Okay? You push on the track, it pushes on you. So in that situation, there's no what? Fc equals forces in minus forces out. What are there none of? There are no forces out. Okay? When you're on the top of a vertical circle on the inside, there are no forces out. There's only forces in. And it can be either gravity or gravity and normal force. All right, what's this force? Gravity. Okay, and what's this force? Okay, is there a situation where that can be 0? Yes. Over the top and actually on the inside, you can produce a feeling of apparent weightlessness. If we're going at the minimum speed, where Fn is 0, you feel apparently weightless. Okay? If you're going really fast and you go over the top of this vertical circle, you'll feel apparently weightless, like in that OK Go video we watched, okay? Where they were in 0 gravity for a lot of the video. Okay? So it's forces in minus forces out, and expect that you're going to have a vertical circular motion problem on your final exam. Spoiler alert, there's a vertical circular motion problem on your final exam. Okay, since we've already talked about artificial gravity, I'm just going to say that obviously that could be one of the 3 types of uniform circular motion problems, but there's also likely to be a multiple choice item about artificial gravity. We did, after all, spend a day on it. Okay. Next thing, that was it for circles. Okay, then we went into gravitation. Newton's universal law of gravitation. Expect a few multiple choice items about that. There will not be a dedicated written response item to that. On your unit exam, that was the net force question between the sun, the moon, and the earth. Right? There's not going to be something like that on the final because I can test universal gravitation as part of satellite motion. Because we have to set mv squared over r equal to that formula anyway. Okay? So there won't be a dedicated problem to Newton's universal law of gravitation, but that doesn't mean you don't need to understand it. Okay? Obviously you do, there's a multiple choice question on it, and it's the thing that provides centripetal force for a satellite. All right, so in terms of understanding, if I double the separation distance between the two masses, that is make R twice as big, what will happen to FG? 4 times smaller. Right, it'll be 4 times smaller. It's an inversely exponential relationship between separation distance and the force of gravity, okay? So, the further away we get, the less attracted gravitationally we will be. What if I make one of the masses twice as large? Twice as much gravitational attraction between them, okay? One of those things doubles, okay, that's going to be a linear relationship with FG. All right? So mass makes a big difference. Mass is the whole reason gravity is around. Okay? It is mass that generates gravity. Okay? The larger the masses, the more the gravity will be. Right? But the further apart they are, the less attracted to each other they will be. Okay, and then we got satellite motion, which is Fc equals Fg. This Fg, not m times g. Now the trick with these was that I don't always give you v. I might give you the period instead, or ask you to calculate the period, okay? Which would mean instead of writing like this, okay, you would have to substitute for v in order to get period and radius in there. Okay, and so if v equals 2 pi r over t, okay, then I would have to substitute, I'd have to square all of this and plug it in there, which would make it look like this. Okay, I got an r squared on the top and an r on the bottom. So that's what that ends up being. Now, something that I saw on the unit exam a fair amount that I want to address. I had a lot of people for satellite motion questions, for gravitational field strength questions, even the universal gravitation question, trying to work this and this into their work. How much did we use either one of those formulas? Very little. Okay? There were 2 questions on your assignment that had to do with this. And those were the only 2 times we used that formula. Okay? It's not something we're ever really going to use. It's just something we had to talk about because it related to mv squared over r. Okay? It's not going to be used to solve any problems on your final exam. Okay? This, I would certainly not waste a written response question on this formula. Maybe a multiple choice, but not a written response. This formula is important because it tells us what affects the speed of something moving in a circle, but it's more important in terms of substitution into a satellite question. Right? So if you're looking for ways to use those 2 things on a question on the final exam, stop looking for ways to use those 2 things on a question on the final exam. Okay? They are not going to help you. Okay? They're not things that we would use on a big multi-mark problem. Okay? All right. Now, the other thing I saw was also people trying to use Kepler's law of periods for satellites, which you can do if, what's the if? Right, if you have a second object orbiting the same central point, right? So people were trying to use that to solve for something like a satellite orbiting the Earth, okay? Yes, the moon also orbits the Earth, but you don't have enough information about the moon to use Kepler's law of periods. Okay? That would be, right, t squared over r cubed equals, right? That's all well and good if I'm talking about two planets orbiting the sun, or a planet orbiting the sun, because then I can use Earth. But if I'm talking about a satellite orbiting the Earth, I can't use that because we have purposely left the moon's period off of your data sheet. Okay? For exactly that reason. It forces you to use the satellite motion formula when we're talking about a satellite orbiting the Earth. Okay? All right, so I would suggest focusing on FC equals FG for the final. It's okay to know about that. It could be multiple choice item about that. But I'm pretty sure I made the satellite question, satellite question, impossible to solve with that. Gravitational field strength is little g. It's acceleration due to gravity. Okay? Its formula is g times m1 over r squared. That mass being the mass generating the field. Okay? The other mass would be caught in the field and as a result cancels, because really this formula is just this. But since mass 2 is on both sides, it cancels, which is important because all things caught in the field at that distance would have the same gravitational acceleration anyway. All things fall at the same rate, regardless of their mass. Now, on your unit exam, the gravitational field strength problem was only a 3-mark question. Ask yourself this: am I going to repeat a 3-mark question on a final exam in the written response? Not a chance. Okay? But it could be multiple choice items about gravitational field strength, what it is, what it means. Okay? But no problem solved.
Will some of the multiple choice not just be a quick treatment of concepts, but
there are some simple calculations if that's what you're asking. Yeah. Okay. Very simple. I would say like a banked curve would be not a simple calculation. Even though that's just FC equals force of friction. It's fairly simple, it's still more than I would put in for a 1-mark question. Okay? A 1-mark question would be, here's some numbers and they don't require you to manipulate the formula. So that would be a simple calculation.
And there's way more written, I guess is worth a lot more.
Yes, the written is the bigger chunk because I can give you part marks in the written. Right? In multiple choice, it's right or wrong, it's machine scored, I got no control over what goes on there. Okay? But I can look for ways to get you marks in the written, and for me, process is important. In the written, I can see your process. I don't see that in the multiple choice. That's why I don't believe in multiple choice diploma exams. Okay. All right, I don't believe you can test everything with multiple choice and numerical response. That's common. All right, number 6. Okay, so gravitational field strength, and that was it. That's what we ended. Gravitational field strength. Didn't have anything after that. Okay, so that's it for circular motion. Okay, that's all the stuff that will be on there for circular motion. The stuff that I've put on the final to do with this unit is the same level of difficulty as the worksheets you got. Okay. So, you know, you got like what, 6 satellite motion questions in the worksheet booklet. There's probably some in there that are harder than what I would put on the file. Okay? Expect I'll probably ask you to do a substitution on the final. Okay? I would prepare for that, and then if I don't, you can be pleasantly surprised. Okay? I would also be pleasantly surprised. But yeah, have a look at that stuff. For the uniform circular motion, you've got a worksheet that's got, what, 12 different questions on curves, bank curves, and stuff like that. Somewhere in the middle of the road in terms of difficulty is the one I put on the final. And same with the vertical circular motion. I think it's easier than the one you had on your unit exam. What are some key words you need to watch out for in this unit if a question's trying to play a trick on you? Apparent, yeah. Okay, if you have something talking about apparent weight, what force is it giving you? We're asking you to get normal force. That's one of those things, okay, be mindful of that. Especially in a vertical circular motion question, or even in a satellite question, it could ask about apparent weight, but probably not, okay? You'd see that mostly in vertical circular motion. What else?
Surface and altitude.
Right, surface, height, or altitude. If you have a satellite motion question that says it is orbiting at this altitude, height, or above the surface, remember that that is not the number you need for R. R is the separation distance between the centers. Okay, so if it gives you that number, you'll have to add the radius of the body being orbited. If it's asking you to calculate altitude, you'll have to subtract the radius of the body being orbited, okay, in order to get the altitude. So that's one of those other kind of trick words that you need to watch out for. Okay? Could also be in gravitational field strength, but I already told you don't have a problem on that. All right, so if there's a unit that might be slightly underrepresented on the final, it's probably this one. Okay, in terms of marks. They're all close, okay? I think the most any one is worth would be about 30%, and the least would be like 21, right? I mean, it should be a 25, 25, 25, 25 split, but it didn't quite work out that way. I'd say if there's one unit that's worth more than everything else, it's 2, which is why we're doing it last. All right, questions from you guys? Anything you want me to go over in a bit more detail or demonstrate or anything like that for circular motion? Because this was the unit that gave us the most trouble, right? Especially on the unit exam. Right? And of course we were out doing online learning for a lot of it.
For a spinning drum question, what's the centripetal force?
For a spinning drum, so that would be an artificial gravity question, okay? And that would be Fc equals Fg, but it would be that one.
Is it going to be asking about tension?
Well, tension can act as a centripetal force, especially if it was like something like the. So if it's a vertical circle, right, tension takes the place of normal force, right? So that's possible, right? It could be something being whirled in a vertical circle on a rope, and then tension equals Fn. Okay, so substitute tension for normal force in that situation. Yeah. What else, guys?
Can you use some bank curve questions?
Bank curve question? Sure. Okay, so at what speed can a 9.5 degree banked curve with a radius of 75 meters be negotiated? All right, so our givens here are theta, 9.5 degrees. Radius, 75 meters. As far as we know, bank curves are only present on Earth. So we would also know G. Okay. Formula for bank curves, tan of theta equals V squared over R times G. And I'm looking for V. Okay, so I gotta multiply both sides by R times G, and then square root in order to get V. Okay, so that would be 75 times 9.81 times the tan of 9.5. Okay, 11 meters per second. Okay, all right, Jim. Anything else? Okay. Substitution or not? With substitution? Okay. That's about as tricky as I could make one. You asked for it, Oliver. All right, so every possible trick is in this one. First off, I see the keywords above the surface, so I know that when I'm solving for R, I'm going to have to subtract the radius of the Earth from this one in order to get the actual height above the surface. It also doesn't give me the speed. If it gives me period and asks me for radius, I have to substitute. There isn't any other way. So I'm going to start off with that substitution and say FC equals FG, and that's going to be M 4 pi squared R over T squared. Okay, so I've just squared the V squared, squared the V equals 2 pi R over T and plugged it in. Okay, equals big G times M1 times M2 over R squared. Now, right off the bat, the mass of the satellite, which I was actually given in the question, makes no difference. Cancel it right away. I need to solve for radius, but I was given period and I was given it in hours. What do I need it to be in? Seconds. This is newtons equals newtons. A newton is a kilogram meter per second squared, so I have to have it in seconds. So 18 hours times 3,600 seconds in an hour gives me 64,800 seconds. I'm going to manipulate now for R. So I'm going to bring this R squared up over to this side so it's on the top and I can solve for it. I'm going to bring T up over here and then 4 pi squared down. So my final manipulation, okay, T squared ends up here. This becomes R cubed and 4 pi squared ends up down there on the bottom. So R is going to equal the cube root. Okay, and that's another thing. People often just take the square root by accident. They write cube root and then they just square root. So we'll have 6.67 times 10 to the minus 11, big G, times the mass of the Earth, 5.98, times 10 to the 24, times 64,800 squared, divided by 4 pi squared. So that'll get us R, and then we'll have one step after that. So we got cube root Okay, so there's my overall radius. Now I need to subtract from that the radius of the Earth. Okay, so I'm going to have 2.9 times 10 to the 2, 3, 4, 5, 6, 7 times 10 to the 7. So 2.9 times 10 to the 7 meters above the surface. Okay, that would be as hard as they could possibly get. Oh, question.
I remember you put like years on it. How do you put that in seconds?
Okay, so how do I get years to seconds? I convert it one thing at a time. Okay, so what I would do if I was told that the period was 12 years, first thing I would do is go 12 and convert it years to days. Okay, so I would go 365.25. Right, multiplying 12 by that. Now that's how many days there are in 12 years. All right, convert that to hours times 24. That's how many hours there are in 12 years. And then multiply that by 3,600. That's how many seconds there are in 12 years. Yeah, so one piece at a time. There's no one number. I mean, there is probably one number I could multiply it by, but that's how I do it. That way I'm sure I don't forget any steps. All right, any other questions there? Okay, couple things about the final exam. Remember that it is a 2-hour exam, right? 2 hours, not 2 hours and an extra half an hour. That's a 2.5-hour exam. This is a 2-hour exam. I don't know why people talk like that. It's a 2-hour test, okay? You must stay in the exam for a minimum of 1 hour. If you are done my exam in less than an hour, you probably didn't do very well, okay? I'm just putting that out there, all right? I have had one person who did finish my exam in 1 hour and 4 minutes and got 100%. But that guy is going to put people on Mars. He was brilliant, okay? He is the exception to the rule for certain. The rule is that everyone else who finished in less than an hour did not do so well, and I ain't getting on that rocket or crossing that bridge if they design it anytime soon, okay? So yeah, if you're done that quickly, you probably missed something, like, I don't know, 2 pages worth of questions. Okay. So yeah, take your time. There's lots of time to finish it, okay? And, but it should take you on average around an hour and a half to an hour and 40 minutes to finish, and then you have time to check it over. That's about what it's designed for.
How many questions?
Again, I don't remember. I was going to go over it in detail on Wednesday. 21 and 12, I think.
Okay. Ours was like 21 like multiple hard questions, if that makes sense, like
Multiple choice, yeah. 21 multiple choice.
Oh.
12 written.
Multiple choice is the bane of my existence.
Yes, but this has actually very few considering it's the final exam.
Yeah, I
Right?
know. That's the weird part though. Everyone's like, oh, multiple choice is easy. And I'm like, it's always 100 on the grid, and then I get to multiple choice, and I'm like, I don't know anything.